Yeah, my name is David Deanna. I am a practice manager at Optiv. I've been in pen testing for over 6 years and in IT and security for over 10. I have a background specializing in host security and in OSINT. And for fun, I like to play video games of all kinds, PC Master Race, woo, everything Star Wars, and play card games like Magic the Gathering in my spare time.
Hi, my name is Lars Kohenauer. I've been a consultant on the attack and pen side of the threat management practice for a little over 6 years. I've also been pen testing for a little over 7. Some of my areas of interest are in Active Directory, post-exploitation, and OSINT. I'm also a gamer, mostly play Destiny with my kids, and then a guitarist, been playing for about 26 years, variety styles, mostly metal, rock stuff. If you want to follow, here's my social media info. Anyways, thanks for coming to our talk.
Well, welcome to our talk. Today we're going to be going over OSINT, and we're going to focus on IP and subdomain enumeration. A couple things we want to cover before we get started is basically a reference to the tool sets that we're actually going to be showcasing here. What we're trying to do is provide detail and results based off of use of free or inexpensive tool sets. You can go ahead and pay for a crazy expensive framework if you want to, like a subscription to it, and likely get better results. But we're trying to work with a very small budget here, because I'm sure most of your companies are not wanting to pony up a bunch of money for OSINT tools and products. Also, there's more than one way to do this. So if you have a method that works better for you, stick with that. You also want to start with a baseline. So when you're comparing tools or some of these new techniques that you might see today, basically create a baseline of information for the search that you're trying to perform, and then just run different tools and run different commands to see if you get better results compared to that baseline. Okay, we're going to go ahead and focus on IP discovery. And one of the things that you'll need to know about IPs is some of the terminology behind that. So whenever we're referencing forward lookups, that's when you're doing a match or a lookup from the DNS name of a record to its respective IP address. In this case, using NSLookup against the optiv.com domain. And a reverse lookup is when you're doing it the exact other way. You're taking the IP address that you know, and you're trying to match it to a DNS pointer record for the domain that you're looking for. One of the major services that you can use is the Aaron's Whois service, which is a public resource. It lets you look up information about IP address information, the organizations that are tied to those IPs, point of contacts that might be registered, and just various information such as like the IP registrar name and the related ASN number that is tied to that specific address. There's a web-based tool that you can use that's hosted by ICANN, which is the Internet Corporation for Assigned Names and Numbers, basically just the body that regulates domain name registration on the internet and ownership for those domains. And you can look up a bunch of information about the specific target, in this case, pretty much a GUI version of the Whois service. One of the cool tools that I've been using recently to try and consolidate some of the efforts to do Whois lookups for global companies or clients rather is the Whois RDAP service. And that basically stands for Registry Data Access Protocol. And it's an alternative because Whois is really, really old. And there's a new service out that uses a different set of ports, different set of protocols. The output's a little bit more usable, and you can search for IPs and domains in what they call regional internet registries, or RIRs for short. And what that lets you do is search pretty much the whole planet for information on specific names. Here's an example of this basically trying to use the Whois tool to try and access a Korean asset. So I had to do a test recently, and this service or this company was way out in the middle of nowhere, and all of its information was in a different language, and I couldn't actually find any information on it. So I used a different tool, and this one is called IP Whois. And what it does, well, actually, you're seeing right there, it's a pretty much a English readout of that same type of lookup, only it's using RDAP instead of the Whois service to be able to pull up that information. In this case, it's hitting up the national registries for Japan and Korea, which is JPNIC and KRNIC. Like Whois pretty much focuses on the ARIN service to try and find information about specific IPs, and the RDAP service uses pretty much the entire internet. There's a couple GUI options, so if you're not really command line centric, you can use either of these tools, OpenRDAP or the RDAP Lookup Tool, to find similar information. In this case, I targeted the Optiv domain because I like to pick on them because I work for them. And you can just see the different layouts of information that come from using those tools. There's also some neat tricks that you can use with even with the basic Whois service. In this case, you can find information that may not be readily available from a command line aspect. So if you're not using the ICANN website and digging into the different record subfields, you could do a search, basically like running a grep command against that service and finding out more information about the specific. Well, actually, right here, down here, it shows a lookup on the email addresses that are tied to that specific domain, and you can see these are some of the addresses that are registered in, or actually documented in the registration record for that domain. Another way you could use the Whois command is by pretty much leveraging the Whois database and using an ASN number. For example, here we have the ASN number that's being used by Optiv.com, and it shows all of the different IP citers that are tied to that specific ASN number, and their information just based off of who owns those IPs within that list. Another way you could do this is the Nmap tool, or using the Nmap tool. I listed off a few flags here that are useful for lookups. The TAC capital R always tries to perform a reverse DNS lookup on an IP to try and identify potentially useful subdomains or domain records that may have been registered to an IP at one point. The TAC resolve TAC all command will look for every address that might be tied to a specific host name. And then the unprived command only sends send packets to each system using a connect call to just ports 80 and 443. Basically, this is useful for when you're running into a situation where you're getting a lot of responses from a system and you're trying to identify what's actually live versus what's not.
The Shodan InternetDB API is like a stripped down version of Shodan that provides limited information. So it will provide like open ports, vulnerabilities, common platform enumeration, but it won't provide data like HTTP headers. It's free for non-commercial use, and it requires an enterprise licensing otherwise. However, it doesn't require authentication or anything like that. For example, here I'm just using a curl command against this to pull down some info. Your main use cases as a pen tester are going to be passive discovery or differential testing. So, for example, if you're seeing services that shouldn't be exposed to the internet, like maybe SMB, for example. You might check this to see if that's actually listening, or if you need to do further scanning. It can kind of give you a quick idea if maybe your client misconfigured an allow list for your IP test ranges. And then Nrich is a tool that leverages the InternetDB API. And it basically is kind of a wrapper, so you don't have to spin up your own tool. So you can just feed it a list and it'll provide you ports, any kind of tags, domain names, and information of that nature. Moving on to Recon by Favicon. This was an area of research I came across while we were expanding the talk out. Some initial research had been done in this area about 10 years ago, and then it kind of died out and it's picked back up again recently. So moving on, we'll first discuss what a Favicon is. If you didn't know, it's the little icon in the corner of your browser. It's just a favorite icon. And so main use cases for these are fingerprinting and asset discovery. Generally, these are going to be located in the /favicon.ico, and get Favicon for Chrome can be used to locate them if they're in like a non-standard location. So for fingerprinting, it uses a MMH3 or Murmur3 hash of the base 64 encoded data. The older tools, as I mentioned, like Nessus and Nmap, were using MD5. However, for asset discovery, you're going to want to use the MMH3 ones because Shodan indexes this information, and so it uses MMH3 for discovery. So we'll get into that here in a minute. Moving on, Nuclei is great for fingerprinting. Has over 500 MMH3 hash fingerprints. It's called favicondetect.yaml, and it also has 5 MD5 hashes in there as well. Then next is Favfreak. Very similar. It also contains around 500 fingerprints, and then you can also have output that will just give you like a Shodan door for the hashes identified, so you can search those later. So for asset discovery, you basically just use this http.favicon.hash and then whatever the hash is, and that will give you a list of any assets that use that same hash. Can be useful for maybe trying to locate assets that are running a specific platform in your client environment. Fav-Up is a command line tool that does some of this in an automated way. It leverages the Shodan API, so you do need a key. I'm using like one of the cheap ones right now that you get on like Black Fridays, and it's working perfectly fine. It will also attempt to identify the IP or the ISP of the IPs that are associated with the assets that it discovers, and then it will dump out a list of IPs. However, I did notice that I was getting different results on the IPs that were turned versus like using the Shodan CLI or just the manual web page. I was getting more results back. So that might be something to be aware of there. However, this did have the most utility as far as what I could feed it. If I had like Favicons in a non-standard location, or if I had them downloaded to my local system, I could feed it a file of those as well to find them. And then finally, just searching Shodan. This is a bit of a contrived example. So I'm using the ASN from earlier. We've got almost 18 million results. Just searching for the Favicon hash for Jira, we had a little over 7,000 results. And then when you combine those search queries, we only had one result. So you can combine these Shodan search operators to narrow down your parameters once you have an idea of what you're looking for.
Okay, and we're going to go ahead and move over to subdomain enumeration. And one of the things that I can't stress enough when you're starting through this process is that your data sources are really, really important. They're going to determine basically which tools you use and what kinds of results you're going to get. One of the first tools we like to use for identifying information is the crt.sh site. So kind of a little bit of background right here. Web security is rooted pretty much in the use of certificate authorities and the certificates that they use. So web servers prove their identity to browsers by presenting a certificate that's signed by a valid CA. And then many CAs publish their certs in a public repo database known as transparency logs. So what crt.sh does is it's basically an aggregate of publicly accessible certificate transparency logs. So there's a tool called ctfr.py. It's a little bit of an older tool that lets you perform subdomain enumeration by querying the certificate transparency log database, and basically it looks for unauthorized, it pulls subdomains of web servers by querying those logs in the database, and then basically puts them out to the screen. And in this case that you see here, I just basically did a search for any subdomains tied to opt.com and grepped out for the primary domain and got the subdomains that are in that list there. There's another tool called Census. Census is basically the search engine for internet devices. It's what they kind of bill themselves as. They use all kinds of different tools generated by the Nmap project. So Zmap, Zgrab, Ztag, ZDNS. And it looks for the most common ports like HTTP, HTTPS, mail services, SSH, that kind of stuff. And even some of the lesser known SCADA, industrial control ports like Modbus and S7, stuff like that. And basically just categorizes the information and puts it here into a nice little package for you. And there's APIs available so that you can use that to basically leverage that in your OSINT searches for domain information. There's another service that's created by Intelligence X. So Intelligence X is an independent European tech company that develops and maintains open source data, search engines. And they use sources like the darknet, document sharing platforms, Whois, public leaks, that kind of stuff, and basically pull all this information together. So here's an example of using the opt.com domain and getting a bunch of different subdomains that are tied to that. You can also use that to get email addresses, so for user enumeration, or just URLs that are exposed as well. What you can do with that information is run tools like Subfinder against the list. And you take the output from Subfinder, tools like it, and then you can pipe it through a tool called DNSX. DNSX is basically a DNS toolkit that lets you perform different kinds of DNS queries, and you supply a list of resolvers. And in this case, what we're doing is we're filtering against all the records that are pulled by the Subfinder to just to find the actual records that are live and filter out the dead ones from the list. So that way, if you're doing a bunch of passive reconnaissance, you're going to get potentially some dead records in that list. So you're trying to get the most concise and up-to-date list that you can when you're using different data sources. You can also filter on different types of records. So in this case, I'm showing that I'm actually looking for IPv4 and IPv6 records in the list there on the right. And this is just some more DNSX shenanigans here, using CNAME records to basically showcase when you use DNS to map one domain name to another. And you basically just get different domain names out of that particular relationship for that record. You can pull that information using DNSX, and you can pull basically just different subdomains, giving if you give it a specific network range using a pointer query. Then we have Subfinder. Subfinder, like I mentioned earlier, is just another one of those subdomain discovery tools that you can leverage for passive subdomain reconnaissance of websites, and it has a custom list of data sources already built in, like census, chaos, recon.dev, Shodan, virus total, all those different options. And you can basically use that to pull a list of subdomains. And then right here, what we have is what I was showing you earlier, which is just a initial run of Subfinder without any flags, and then piping that information through the NSX to show the valid subdomains that actually exist. So this is actually an older domain owned by Optiv before the merger that they had with Activant and Fishnet back in 2012, 2016. It's been a while. Anyway, there's only 2 records that are actually live that are currently being used for that specific address right there. And then this is another tool called Altdns. So if you're having a hard time trying to find a good list of subdomains, you can actually use a mutated list. You can basically pull a bunch of words from, like, say, the company's website, or just a random list if you have it available, a word list to basically mutate the domain names. So you can add like a 01, iterate, through a list of different types of names, try and see if maybe they have some really weird named, systems or domain names, or subdomain names rather, available for reconnaissance. Okay, and here's another example of using Sublister and pulling out a bunch of information just straight from the different data sources that are listed here. All right, and then what we have is ViewDNS. So ViewDNS.info is like a Swiss Army knife. It has a bunch of different options or utilities available to you. Basically, it lets you search for current and historic Whois records by using fields like the name, maybe like a phone number or email address that was registered for a specific domain. So if you have a specific email and it's a contact for the domain that you're looking up, you can also find things like other domains that are registered under that email address. So it's really good when you're looking for like shadow IT domains that may have been stood up, or you're just looking for additional areas to add to the attack surface. Right here is an example of a reverse Whois lookup. So again, this is showing what other domains that this specific customer owns, and it's good for identifying potential host names for any specific, say like in-scope IPs that your client may have provided on a pen test that you just can't resolve to. And as Lars mentioned earlier, Shodan's a really good tool for performing all kinds of different scans to look up information on targets, and also it's kind of like the difference between Google and Shodan when it comes to pulling information is that Shodan captures the banners or the metadata that's exposed on services to identify assets. Google just crawls the web looking for information on specific targets, and Shodan crawls the entire internet. So not just on web ports, it looks for pretty much all devices connected to the internet. It's also updated almost all the like constantly. You have to have a subscription to get access to the API, but it is a really powerful tool. Like it's a good IoT search engine. So next, we're going to talk about Amass, and I put one of my favorite cards in here to kind of show you what Amass can do. Basically, it's just a really, really powerful tool. We're going to hit up 2 different modules within Amass. The top 2 there, Intel and Enumeration. The bottom 2 are just for visualization purposes. So the Amass Intel module is for evasive testing. So you're not actually doing any active reconnaissance at this point. The image on the left is basically doing a substring search for a company name to see if they have any subdivisions around the world. So if Optiv had different named like companies or subdivisions, we'd be looking for variations on a theme, looking for that specific name. And it's also good if you're looking for like acquisitions or merged companies where they took on part of the company name as well. The other screenshot shows some reverse DNS lookups that were performed against a specific IP scope that were provided by the client that we're working with. In this case, it's all Optiv stuff. It's not an actual client. And the subdomains that are enumerated here, they show different domains owned by that client that weren't shared in the scope. For example, it's showing some of the hosted providers that Optiv actually references for, or I'm sorry, leverages for some of its IP space. Okay, then we move on to the enumeration module. So this is where we're dealing with active type of recon. You're going to have a much better performance improvement using this version of, or I'm sorry, this module, because the Intel is portion is very, very slow. One pro tip is if you specify the no alts flag, it will disable alterations of host names. Because if you use the alterations data source, it'll send a ton of traffic over the wire. And if the argument isn't included in the command, it'll just flood basically it'll just take forever. You'll just get a ton of records and ton of information that you're not looking for. Let's see. And when you're seeing something that says brute force in your output, the difference between traditional DNS brute forcing and say like alterations is that DNS wordless brute forcing is considered to be like a dictionary attack, where you have like bob.optiv.com or sally.optiv.com, and alterations is like saying vpn1.optiv.com and vpn2.optiv.com, things like that. So it's just extra data that can be sourced from a file, either a text file that you provide or one that's provided within the GitHub installation for Amass. And right here, what we have is an example of running an Amass scan against the Optiv domain. In this case, we have 46 subdomains that have been identified. However, that was just running Amass without any specific flags related to any of the data sources that we could potentially leverage. So right here, what you're seeing is an example of a couple of the different data sources that I specified by leveraging different API keys for the services that I had access to. And by creating that list and actually identifying additional DNS resolvers, you can potentially increase your gains or your yields by looking through additional repos of data sources that aren't the default that are used by Amass. In this case, we bumped up our list to a healthy 52 subdomains. Again, some of this was from hitting up different sources that weren't specified originally, and there was a little bit of brute forcing that was involved there because I had that specified within the command as well. If this was against a much larger organization, like say Microsoft, you could get a potentially dramatic increase in your attack surface as far as like what you're actually able to identify by specifying unique and varied data sources. So one of the other things that we like to do when we're doing lookups is leveraging ASNs. So the autonomous system numbers are like the zip codes for networks that the internet is made up of. So if you look at this little graphic here, you see different areas of the globe and ASN numbers that are tied to those. Pretty much what they're for is to help you identify who owns a large group of CIDR blocks of IPs. And also for identifying IPs that are owned by virtual hosting providers, and then what the subdomains are that are registered to those IPs. So there's a bunch of different ways to leverage ASN numbers for lookups. First one is just using the Aaron.net site. And, we're doing an RDAP query here, looking up the IP address for optiv.com. So I did a host command, pull that up, and then there's the result showing the AS number of 19551. There's another tool that's really awesome for leveraging ASNs, and that's the Hurricane Electric BGP toolkit. Lets you search for company name, IP address, CIDR ranges, and ASN numbers themselves. And if you do a search for the company name, it'll give you a list of ASNs and the related CIDR IP address ranges that are tied to those ASNs as well. While the information isn't always relevant to what the target you're looking for, you can also get additional ASNs in the results as well. And here's just another couple screenshots showing some of the output from those. And if you notice there, you can actually get not only IPv4, but IPv6 information about some of the peer networks that are adjacent to the specific ASN that you're looking up. Or I'm sorry, the ASN value that you're looking up. Nmap also has an NSE script for ASN lookups, because why not? I mean, NSE scripts are awesome. And in this case, it's just dumping out that same list of IPs, looking for anything tied to that one specific ASN number. Amass also has ASN lookups through the Intel module. Again, if you just feed it the TAC ASN flag, you'll get potentially the entire list of subdomains that are tied to that ASN number. The problem with this, I mean, it's still a passive lookup, right? Because you're using the Intel module, but it also is very, very slow. This could take potentially hours, if not days, if it's a massive group of CIDRs that you're actually combing through. But which should show you all the domains that are registered to that specific ASN. And again, this is all about extending the attack surface and finding additional potential domain subdomains that are tied to the target that you're going after. There is another tool that's out there. This is a little bit older too. It's ironically called the ASN Lookup Tool, and you can look up information based off of the org name that's tied to that specific ASN, like who owns it. Get information about where it's physically located, like geolocation information. You can get IP reputation. You can find out, like, is it part of a known, bad type of block of IPs, and also, is it hosted or like basically like locally owned or whatnot type of configuration. You can also do ASN lookups via Shodan, because just like when Lars was talking about the Favicon stuff, this is just yet another awesome way to look up information via the Shodan tool. So pretty much that's the gist of what we have for you guys today. What we also have at the very end is an awesome list of resources and repositories that we've used and we'd like to share out as well. So pretty much most of all the tools that we listed off here are the GitHub links for the majority of those, and obviously the URLs for the GUI tools that we're referencing as well. And then there are a few other awesome sites that you can view for learning more about subdomain enumeration and just OSINT in general. I definitely recommend that you guys check out the site that we have at the bottom for the Start Me page. Basically, I collected a bunch of different resources to pretty much like help in every single area of OSINT that you would need for a pen test. But like we have here, there's like a ton of different areas in websites out there that you can learn more information about what we've been going over through this talk. Lastly, if you guys haven't, I'd recommend you go on Twitter and start basically doing searches on every OSINT personality that's out there to try to get more information and kind of get connected to the community to be able to not only learn more about OSINT, but also to start giving back a little bit too. If you guys have any questions about our talk or anything that we've covered here, because I know we kind of blew through a lot of it pretty quickly, feel free to hit us up on any of the platforms that we mentioned earlier in the talk. And otherwise, thanks for your time.